Okay, in the given question, one end of copper rod of uniform cross section. Uniform cross section is noted, so area will be constant. So, one end of copper rod of uniform cross section and of length is given as 1.5 meter. So, if the whole system is insulated, length 1.5 meter is kept in contact with ice at 0 degrees centigrade. So let us take a copper rod of uniform cross section. One end is kept in contact with ice which is at 0 degrees centigrade. So one end is kept in contact with ice at 0 degrees centigrade and other end with water at 100 degrees centigrade. So another end water 100 degrees centigrade and the length of copper rod is given as 1.5 meters. So what he is asking, if the whole system is insulated from surroundings. So this is our system. This is our system. He gave that the whole system is insulated from the surroundings. That means the heat is not transferred from the system to the surroundings. And then at what distance from the end of rod which is in contact with steam. So rod end which is in contact with steam. So we have to find the distance from the point on the rod to the end which is contacted with steam. So this is the point. Then at what distance? The distance is, let us consider the distance is x. The temperature should be maintained at 200 degrees centigrade. So he gave that this point, the temperature should be maintained at 200 degrees centigrade. So that in steady state, the rate of melting of ice, this is also to be noted, rate of melting of ice will be equals to rate of production of steam. So rate means mass of ice melted by T per unit time should be equals to mass of steam produced per unit time. So as time get cancelled, mass of ice should be equals to mass of steam. So what we have to find is the distance of x, so that the point, let us consider the points A, B and C. So the temperature at point C should be maintained at 200 degrees centigrade. So temperature at point C should be 200 degrees centigrade. The value you have to find is x. So as it is x, total distance is 1.5. We can take it as 1.5 minus x. So the main concept involved here is rate of loss of heat, delta Q by delta T is equals to Ka delta T by x. So I'll explain the terms here. Delta Q by delta T is rate of loss of heat. K is thermal conductivity. A is area of the rod we have taken or the body we have taken. Area of body. So next, delta T is change in temperature. And x is thickness of body. Okay, the terms here is K is thermal conductivity, A is area of body, delta T is change in temperature and x is the thickness of body. So first we have to take, we'll move this delta T to this side, so delta Q will be K delta T delta small t by x. So we know that Q means energy, that will be mass of some body into latent heat. So if we take Q of ice, then it will be mass of ice into latent heat of ice. So let us substitute it here. Q of ice will be K. A is area of the rod, so let us take it as A only. And delta T will be T theta minus theta is this. Let us take it as theta, theta of ice and theta of steam. So for ice it will be theta minus theta ice. T will be constant. And so heat is coming from steam to ice. To melt ice, we are getting heat from steam. So we have to consider the distance is x. So mass of ice into latent heat of ice is equals to K theta minus theta ice T by x. Let us consider as equation 1. So we have taken for ice. Now let us consider for steam. Q of steam. Similarly, K and A will be constant because we have taken it in the starting. A is constant throughout the rod. Ka theta minus theta steam into T by. Here the distance will be changed because the heat is now transferred from ice to steam. That will be 1.5 minus 6. Mass of steam into latent heat of steam is equals to Ka theta minus theta steam into T by 1.5 minus 6. So let us consider this equation 2. Now let us divide both equations. Equation 1 divided with equation 2. We know that we have considered here mass of ice should be mass of steam. So left side mass of ice and mass of steam will be cancelled. Latent heat of ice by latent heat of steam is equals to theta minus theta steam into 1.5 minus 6 by theta minus theta steam into x. So let us substitute the values. Latent heat of ice will be latent heat of fusion, that is 80, and latent heat of steam will be 540. So 80 by 540 is equals to 200 minus ice temperature is 0 by 200 minus temperature of steam is given as 100 into 1.5 minus x by x. So here it will be 8 by 54. So we put 4 by 27 is equals to 200 by 100 to 1.5 minus 6 by x. So let us solve this. 4 by 27 is equals to 2 into 1.5 minus 6 by x. So it will be 4x is equals to 2 into 27 into 1.5 minus 6. I'm solving. 4x is equals to 54 into 1.5 minus 6. 4x is equals to 54 into 3 by 10. It will be 27 minus 54x. So on solving, x will be 139.6 centimeters. So here they gave in meters, but we have to convert it into centimeters. So last answer will be x is equals to 139.6 centimeters.